Okay, so this video we will talk about L'Hopital rule. Okay, so hopefully you guys done your reading for the L'Hopital rule. So a lot of time I read it at the Hospital, but it's just L'Hopital. But anyway, for the L'Hopital rule, you need to have the function f of x in the form of what we call indeterminate form, right? So the indeterminate forms are the form include as the form include as if you have 0 over 0, right? As you know, 0 0 over 0 divided by 0 is not acceptable, right? So that's one form. Or you have infinity over infinity, or you have negative infinity over negative infinity, or even positive negative infinity over positive infinity, or any positive infinity over negative infinity, or you have 0 times infinity, or infinity times infinity, right? So these forms are indeterminate form, right? So once you have the form like this, you will want to have to use our L'Hopital rule, which if you already know that the L'Hopital, you would take the limit of x approaches a of the derivative of the top and the derivative of the bottom. So let's say if you have f of x is, if you have h of x is equal to f of x divided by g of x. The L'Hopital rule is the derivative of the limit of x approaches a number a of f prime of x and g prime of x, right? So you keep doing it until that you can take the limit. That's until that you don't have the form 0, any of these indeterminate form, right? So as an example of a L'Hopital rule, so that you could think about it is, let's say if you have the limit of x approaches 0, I'm gonna do a one hand side. That approaches 0 of, let's say, 5x times the natural log of x. Okay, so as you know that if I do direct substitution for this one, because that's always the first step, that when you take a limit, you see if you can do direct substitution, right? So if let's see if I do direct substitution, then I have the limit of x approaches 0 from the right hand side, 5x is going to be equal to 0, and the limit of x approaches 0 from the right hand side of natural log of x, that will give us the negative infinity, right? Because the natural log of x, the natural log curve is, it doesn't do, if you graph it out, trying to plot it out, your function for the natural log curve is something like, that's a bad drawing, but anyway, so let me continue it down here. It goes something like that, right? So as x approaches 0 from the right hand side, right, then it goes to negative infinity. All right, so let's say if you have this problem, that means that you have, if you do direct substitutions, you have a form of 0 times infinity. This is a form of indeterminate form, right? So you need to use L'Hopital rule, but in order to use L'Hopital rule, you do want to have it in these main form, 0 over 0 or infinity over infinity, or any of these variety here, right? So you want to have fractions. That's what I'm trying to say, right? But so in order to convert this into fractions, which you could do is you could multiply the top and bottom of this limit, right? So let me just erase this for a second. You just think of as you're not going to change the function. You're going to multiply the top and bottom of this limit by 1 over 5x. right? So notice that this is basically 1, right? You multiply it by 1. So if you do that, then if you simplify at the top, you will have something such as the limit of x approaches 0. I always like to carry my limit because then I will know what I'm doing. I take a limit of 5x times the natural log of x divided by 5, and that also divided by 5x, then that the whole thing divided by 1 over 5x, right? So by doing that, you can cancel the 5x out. Now you have, what you have left is the limit as x approaches 0 from the right-hand side of natural log of x divided by 1 over 5x, right? So now if you do the rest substitution, then you have if x approaches 0 of the natural log, you have something such as I'm going to do an error here, such as the top you have negative infinity, and then the bottom, since it's 1 over 5x, then the bottom will go to infinity, right? Infinity. Right, so this is one of the indeterminate form. So you could apply the L'Hopital rule, right? So I usually do, okay, look, in this form, I can do L'Hopital rule, as that. That means I'm going to take the limit as x approaches 0 from the right-hand side of the derivative of the top, which is derivative of natural log of x, which is 1 over x, and the derivative of 1 over x, 1 over 5x, right? So on the side, we can do, let's say dx 1 over 5x is the same thing as you say dx of 5x to the negative 1, right? So if you apply the chain rule, you have a negative 1 times x times 5x times 5x to the negative 2, and then multiply the derivative of the inner, which is 5, right? So that is the same thing as you say negative 5 times 5x to the negative 2, right? So that is it. So if you put it back in here, you have that derivative, it should be negative 5, oops, my bad, sorry, divided by 5x squared, right? So, and notice I put parentheses, otherwise I would just trying to cancel that, right? So once I have that, let's see if I can simplify a little further, okay? So that is the same thing. So since you have fraction divided by fraction, the bottom fraction will be flipped, multiplying, right? So you got the same thing as the limit x approaches 0 from the right-hand side of 1 over x multiplied by 5x squared divided by 5. And I'm not gonna lose my negative, so I brought my negative out in front, right? So I have a negative there. So that's the same thing as now I could say that, okay, I can simplify anything else. So I have this is the same thing, 5x squared is the same thing as if I write the limit as x approaches 0 from the right-hand side of negative 1 over x times 25x squared over 5, right? And 25 and 5 can cancel out. And that's leave me up here is 5, and this is 1, right? And don't forget here I have an x and I have 2x, that can cancel that out too. So that is the same thing that we said the limit as x approaches 0 from the right-hand side of x, 5x, sorry, 5x divided by 1, right? So, and don't forget your negative 5, a negative there, divided by 1, right? So we have a negative there, so we're going to carry that out. So now, let's see. if I plug 0 in for x, right, I can, since 5x continue everywhere, I can do direct substitution, right? So now this limit is going to be equal to 0, right? Because there's no 0 in the denominator, or no form of infinity over infinity or anything like this, right? So therefore, this limit equal to 0. All right.